Hi, this video is on trig modelling in the trigonometry or circular functions unit. Learning intentions are that you'll understand how things in the natural world can be modelled by trig functions, how to find the period by considering the dilation in x and vice versa, interpret trig models in terms of real life problems, and you'll have to be able to sketch trig functions, so we'll go through some of that as well. And the one we're going to be looking at is involving a problem involving the tide. So you can imagine that sea level starts at a particular point and then it's going to rise and then it's going to fall over time and rise and then fall over time. If we track that out over time, what we get is that rising and falling, and it's producing that familiar pattern, the sine wave or cosine wave. And most of these problems could be described in either sine or cosine because both have just been translated one way or the other, so you can make one from the other. The first problem we're going to have a look at is described in terms of cosine, and it's this one here. The height of the tide in a harbour can be modelled by the equation h equals 5 plus 2 cos pi over 6t, where height is the height, h is the height in metres of the tide, and t is time after midnight. So these are the questions we're going to be looking at. The first one we're going to look at then is A, what is the height of the high tide and when does it occur in the first 24 hours? Okay, so we would be able to get an idea of what this is going to look like just off a rough sketch. We know that cosine starts off life looking like that, and this has been dilated by a factor of 2. It has an amplitude of 2, so it's actually going to end up being like that, so 2 and negative 2 instead of 1 and negative 1. And it's also been translated 5 up, so instead of going from minus 2 to 2, it's actually going to go from 7 up here to 3 here, and it'll have a line there at 5 in the middle, and it'll look like that. Okay, now the height of the high tide then is going to be 7 meters because that's what it's measuring in. That's going to be the highest point. And when does it occur in the first 24 hours? Well, because it hasn't been shifted left or right, it's going to start here and finish there. So it's going to be at 0 hours. But we need to know what the period of this function is, so whether it may happen once in 24 hours or it may happen twice in 24 hours, or we would have to keep going like that. Now, to work out the period, remember that equals 2 pi over n, and n here is this value, pi on 6. So if you think about this in general terms, our function can be described as a cos n x plus b. So in this case a is 2, n is pi on 6 and b is positive 5 here. So n period is 2 pi over n is pi on 6, so the period is 2 pi divided by pi on 6, which if we write it in terms of multiplication is going to be 6 over pi, and as you can see this is going to cancel nicely, leaving us with 12. So the period is 12 hours. Now that means that this happens after 12 hours and then it's going to happen again, taking us up to 24. So that high tide occurs at 0 hours after midnight, 12 hours after midnight and 24 hours after midnight. So we could say midnight, 12 noon, and then midnight again if that was included. It's not entirely clear from this as to whether we would include the end point there or not, but we can see that that's when it would happen, midnight and 12 noon, then the subsequent midnight and so on. So there we go, that would be the height of the high tide, 7 meters, and it would occur at these times. Now, if we have a look at the next one, question B, what is the difference in height between the low and high tides? Alright, so our sketch now was between, what was it, between 3 and 7. And remember it had that kind of mean line there. Once and twice. So the high tide is 7, the low tide is 3 meters, so the difference in height there is 4, which is, there's a couple of ways you could work that out, either by looking at those numbers or by knowing the amplitude was 2, and it's going to be 2 lots of that. But either way, it's going to be 7 minus 3, so it's 4 meters, or 2 lots of the amplitude, which again is 4 meters. Okay, C. Okay, so to sketch this, let's just go through all the steps we need to. So we'll start off with, it should be H. So H is 2 cos pi on 6 t plus 5. Oops, t is between 0 and 24. Okay, basic shape we know is cosine is like that, between 1 and minus 1. So there's our basic shape. It's got an amplitude of 2, which is going to take it up to 2 and negative 2. Now the period, as we've already worked this out, but remember to always write this out, period equals 2 pi on n. So it equals 2 pi divided by pi on 6, which as we know is 12, because that's like multiplying by 6 over pi. So the period is 12, which means it's going to occur twice within 0 to 24, so we're going to get 2 full cycles, so it might be worth making a note, therefore 2 cycles. And it's also translated 5 up. 5 units up, which we know from there. So that's everything now. So if we sketch it, just make sure we draw some nice axes. Now we might include that mean line just to help us draw it. Now it started out, the mean line started out as the x-axis, and then we moved it up 5, didn't we? So there's going to be that mean line there to help us draw it at 5. It's going to go up to 7 at the top, it's going to go down to 3 there. It starts there. Now if this is 0, 12 and 24, and this is t here, we should also label h is that axis, and it's going to come all the way up to there and then go all the way up to there again, and the lowest point is going to be here, lowest point is going to be there, that's at 3, and then we should just try and sketch it in as best we can. Try and keep it fairly neat. There we go. Now we should always label our endpoints. These are included, you'll notice. So I've used those blobs like that, so they're included. And that is 0, 7 and 24, 7. At least one turning point should be labelled as a rule of thumb, so I could have that as 12, 7 as well. Now there are no other intercepts, so there's nothing else to solve here, and that would be sufficient. Or maybe I should really label one of these as well. It'll be halfway between, so it's going to be 6, 3. There we go. Okay, so the height of the tide in the harbour can be modelled by that equation. If the trawler needs a depth of 6 metres to enter the harbour, between what hours can it come in? So if we have a look back to our graph that we just drew there, at 6 metres, if I draw a line through 6 metres, that's a little bit high, I'll just put it down there. There we go, that gives us an idea of what we're trying to find. So it's all the points at which it's greater than 6 meters. That's when the trawler can come in. So from here to this point, from this point through to there is okay. So it's sometime between midnight and here, sometime before and after midday, and this time before midnight again. Now there's a few ways we could solve this. Now one is just going to be to set this equation equal to 6 and solve, and there'll be 4 solutions there, and we then interpret them. Another way could be just to find this first one here, and then because of the symmetrical properties here, we should be able to work out what this and this are, because if I know this value here, I'll also be able to work out what that value is, and that value, just by coming up and down by the same amount. Alright, so the first thing we need to do is try and solve 5 plus 2 cos pi over 6t is equal to 6. So if you rearrange that, and this is t is between 24 and 0. So cos pi over 6t is equal to, if we rearrange that, we're going to get a half. And we could go back to how we've solved these before. So let a equal pi over 6t. Change this to pi over 6t. That's still going to be 0 because you're multiplying by pi over 6. If you multiply this by pi over 6, I'm going to get 24 pi over 6, so it's going to cancel down to 4 pi. So I'm solving cos A is a half, and it's A is between 4 pi and 0, so it's twice around the circle, or 2 whole periods or cycles, which is going to give us 4 solutions, which should be no surprise here. As you can see, once around the circle, twice around the circle, 4 solutions. So we could solve it like this. That would give us A would tell us that's pi on 3, and then we would go twice around the circle and find out what they all are. But I reckon we should take a shortcut here. Let's just work out this first solution. So A is pi on 3. Let's see, A is pi on 3. A is pi on 6t. So pi over 6t equals pi over 3. T equals, so if I multiply by 6, I'll get 6 over 3, which will cancel down to 2, and pi will cancel out here. So t is equal to 2. Now, look back here. If that's 2, as you can see I've already marked this on actually, if that's 2 there, then I can go from 12 to this way, because it's symmetrical, so it's going to be 10, and 2 this way, so it's going to be 14 hours after midnight, or 2 in the afternoon, and 2 hours back this way, which will be 10 o'clock at night. So, using the kind of symmetry, using symmetry in the graph, I'm going to get between, t equals 2, 10, 14 and 22. If you want, you could work out all of those different values of pi on 3, 2 pi minus pi on 3, 2 pi plus pi on 3, 4 pi minus pi on 3. Rearrange and you'll get all of these things anyway. But I'm just using the symmetry of the graph to get those results there, which saves a little bit of time. So then just got to interpret that. So between what hours can it come in? So it can come in between 10 p.m. to 2 a.m. It can come in, and 10 a.m. to 2 p.m. Between those times it's okay, and between those times, if you like, it's okay. If you have a look back at the graph, it makes that a bit clearer. So it's okay between 10 a.m. and 2 p.m. and then it's okay between 10 p.m. and 2 a.m. Alright, so just about out of time. Sorry that was a long video. I'll re-record this and do a better version of it sometime. but that should get you through some of those modelling questions. Okay, bye bye.